have time to get into all those. Okay, the last one of angle, last example on angle in positive direction, because we need to have time to do parallelogram law. Find the magnitude and positive direction of the vector. So let's name this vector u. Vector u implies 1 comma negative square root of 3. All right. So first of all, let me find the magnitude of the vector u. The magnitude is square root of the x component squared plus the y component squared. But if I'm squaring any negative number, the answer is still negative. Therefore, the magnitude of this vector is going to be square root of 1 plus 3. And square root of 4, and it's actually going to be 2. We're not doing negative plus or minus because it's absolute value. So the magnitude of u is 2. The magnitude of u is 2. So we found that. Okay, magnitude of u is 2. Then the positive direction of this angle. So we want to draw. When I'm told to find positive direction, I draw because I actually want to know which quadrant that the angle is. It helps a lot. Makes your work easier if you know the diagram. If you know where the quadrant in which the vector is. Okay, so this vector again is in the fourth quadrant. This vector is in the fourth quadrant. All right. So it's a vector, so you need to have an arrowhead. And the initial point is right here. The terminal point is right here. So I have 1 negative root 3. Okay. But I need to find the value of this angle, the reference angle. For me to find the value of that reference angle, I need the angle theta. It's not given to me. Okay, so the y component is negative square root of 3, but I'm just going to solve by 3. Okay, and the x component is 1 right here. By the way, this is the component form. If you're told to write your answer in component form, this is component form. If you're told to write it in rectangular, in a trigonometric form, then it becomes 1 cos angle. I don't have the angle here. When I finish, I'm going to write. Okay, so now I'm looking for the angle theta. I have the opposite, I have the adjacent, so I can use tangent. Tangent theta is opposite. I'm going to omit the negative here. Root 3 over 1, opposite of the hypotenuse. Okay. Okay, so now I'll find tan inverse of root 3 over 1. And by the way, if I draw a special right triangle, and this is 60 is opposite root 3, and this is 2, and this is 1. So tangent of 60 is root 3 over 1. So actually, the angle is, the reference angle in the fourth quadrant is 60 degrees. So this angle is 60 degrees. And since this angle is 60 degrees, the angle in the right, in counterclockwise direction, the positive angle is 360 minus 60. 360 minus 60 is 300. So the angle in question in positive direction is 300. So the direction angle is 300. So be careful when you're told to find the positive direction. They want to know that you know your unit circle. They want to know that you know your unit circle, positive direction angle, and it's already in the test. We have done 2 of them, so we have tried. So the next thing now we want to do is find solve problems on parallelogram law. If we can do 2 of them before the time is over, because that is the application that, oh, we haven't actually done the Heron's formula. Okay, we're going to get to Heron's formula because the Heron's formula is in the test. The Heron's formula is in the test. Half AB sin C is in the test. Parallelogram law is in the test. So I just want to make sure we do one of each. That way you can remember that. Okay, so anytime, let's draw a parallelogram. Remember when you were in geometry? When you were in geometry, we want to look at the properties of a parallelogram. A parallelogram is a quadrilateral with opposite sides parallel, equal and parallel. So equal and parallel. And so this, forgive my crooked diagram. Okay, so opposite sides are equal and parallel. Equal and parallel. Well, the diagonals does not bisect the angle. I hope you remember that from, that is, the diagonals of a parallelogram does not bisect the angle. So if this angle is 100, you do not expect this one to be 50, and this is 50, no. Okay, so let's actually use, I need to redraw this. So we want to solve this problem using parallelogram law. And by the way, that's what we are told to use though, parallelogram rule. So I want us to see that the vectors are going in different directions. And that's why it should be. So all I need to do is complete a parallelogram of that vector. Okay, and I'm going to draw a diagonal, even though the diagonals does not bisect each other. I still have to draw a diagonal. But what do I really know? I'm given that this angle is 60 degrees. Adjacent angles of a parallelogram are degrees. So if I know that it's 60, this is 120. If I know this is 60, this is 120. Okay, so, but the angle here is not 30. This is not 30. You don't want to do that. So use the parallelogram law to find the magnitude of the resultant. So this is the resultant. The diagonal is the resultant vector. The diagonal is the resultant vector. So let's see what we have. We have that this force here is 14 pounds. And this force here is 3 pounds. So we have enough information to solve the problem. We do have enough information to solve the problem. This is also 3 pounds. Remember that opposite sides of a parallelogram are equal. So we have 2 congruent triangles. I'm going to bring one out. Okay, I'm going to bring one of them out. All right, so bring one of the angles out, one of the triangles out. I have this. What do I know? I know that this is 120 degrees. I don't know this angle, but I know that this is 3 pounds and this is 14 pounds. I have enough information to find the resultant vector. The resultant vector is this big line. But which formula do I use? Do I use the cosine rule or sine rule? I want you to watch that I am given one angle and the adjacent sides. 2 sides and an included angle. So this is a candidate for cosine rule. Therefore, the resultant force is equal to 3 squared plus 14 squared minus 2 times 3 times 14 cosine of, I didn't give this a name, but you see cosine of 120. You apply unit circle again. Cosine of 120, by the way, 120 is in the second quadrant. Cosine is negative in the second quadrant. The reference angle in the second quadrant of 120 will be 180 minus 120. 180 minus 120 is 60. So cosine of 60, we already know it is 1/2. So we rewrite cosine of 60 is 1/2. So this is 3 squared plus 14 squared minus 2 times 3 times 14. Cosine of 60 is 1/2. One thing we need to remember is that the sign here is negative. So this sign changes. You got to be careful because that sign is negative. Negative is positive. So these two will cancel this. And so let's find the side. The side that is the resultant force. I put my calculator up. And I can now find the square root. Square root. Because you know I'm going to square both sides. So I'm going to clear square root of 3 squared is 9. I can just go put 9 there. Plus 14 squared. Plus 3 times 14. 3 multiply 14. Okay, and that's it. All right, so I have to check and make sure that I got it right. 9 plus 14 squared plus 3 times 14. We have taken care of the 2. And when I hit enter, we found the resultant force. Of course, the resultant force cannot be negative. Round to the nearest tenth. Therefore, the resultant force is 15.7. The resultant force is 15.7. 15.7. So see how we used the parallelogram we learned from geometry and cosine rule and unit circle to solve a problem. One more. Let's do one more problem on parallelogram law. One more problem on parallelogram law. It's already in the test. I think number 21 is about parallelogram law. So let's do number 21. The two vectors are on opposite direction. I have to draw a diagonal from the middle of them. Complete. So complete the parallelogram. And what's a crooked parallelogram? Crooked one. All right. All right. So complete the parallelogram. Okay, much better. And then the opposites, see the force. Here is 6. The force here is 11. They're in pounds. Opposite sides are congruent, of a parallelogram are congruent. The diagonal has got to go between the two forces, the two vectors. So the diagonal is the resultant force that I'm looking for. That is the resultant force. Okay. And this is R. The diagonals of a parallelogram does not bisect each other. But one thing I do know is that adjacent angles of a parallelogram are congruent. So 180 minus 114. 180 minus 114. So I have 180. Take away 114. And I have 66 degrees. So the angle here is 66 degrees. 66 degrees. And the angle here is also 66 degrees. Opposite angles are congruent. Opposite angles are congruent. The diagonals does not bisect the angle. Okay, now that I have drawn a diagonal, I can just bring one triangle out. Bring one triangle out. And then this angle is 66 degrees. This is 11. This is 6 here, and this is 11 here. Okay, and this is the resultant force. And again, I cannot use sine rule here because I'm given two sides and an included angle. This is a candidate for cosine rule again. So r squared, the resultant force, is equal to 6 squared plus 11 squared minus 2 times 6 times 11 cosine of 66. And then I can pull them into my calculator like that. So I just get my calculator clear. And then I want to find the square root of the quantity in the right-hand side. So I do second square root. And then I put that 6 squared plus 11 squared minus 2 times 6 times 11 cosine, multiply cosine of 66, multiply by cosine of 66, close parenthesis. When I hit enter, I have 10.16. Therefore, the resultant force is 10.16. To how many decimal? Nearest 10, 10.2. 10.2 pounds is the resultant force. Okay, 10.2 pounds is the resultant force. All right, so we have done two parallelogram laws. The next thing we want to do is Heron's formula. So find the area of a triangle by Heron's formula. So let's find a question on Heron's formula here. And at the end of that, we are ready for the test. Our test number 3 will open, test and quiz will open in the morning and close by midnight. Unit 4 test will open next Friday and close by midnight. When the Unit 4 closes, I'll put in the final exam. Because after Unit 4, by the way, Unit 4 has 5 sections, 11.4 to 11.6, 8.1 to 8.2. So we are gone more than half. We're almost done. So the next thing we want to do now is Heron's formula. The Heron's formula. I hope it's in this and this. I hope it's in this, but it's already in the test though. So Heron's formula is in the test. If it's not here, I'll find it somewhere else. All right, so we are looking for find the area of a triangle using the Heron's formula. And by the way, you may not be told what to use. The question can say, use the appropriate formula. So nobody tells you, no one tells you to use the Heron's formula. It is your responsibility to know that it's Heron's formula. Nobody tells you. So let's go. I'm going to use Heron's formula. We know it from a geometry class, Heron's formula. So they won't tell you which formula to use. You have to figure out which one. So area of a triangle. By the way, let me just sketch a triangle. I'm going to sketch that triangle. A, B, C. where the side opposite A is small a, side opposite to B is small b, small c, small b, and small a is 15 meters, small b is 10, small c is 13. Okay, so we are ready to find. Okay, so there's something called S, and S is called semi-perimeter. S is equal to semi-perimeter, which is half of perimeter. And perimeter is the sum of all the sides. Semi-perimeter. All right, so, and semi-perimeter will be 15 plus 10 plus 13 divided by 2, semi, which means you're going to divide it by 2. 15 plus 10 is 25. 25 plus 13 is 38. 38 divided by 2 is 19. So semi-perimeter is 19. That is 25 plus 13 is 38 divided by 2 is 19. So our semi-perimeter S is 19. Now we write the Heron's formula. So by Heron's formula, area equal to square root of semi-perimeter into semi-perimeter minus A, semi-perimeter minus B, semi-perimeter minus C, and then simplify. So we're going to just put it in. So our A is equal to 19 into 19 minus, let's see the numbers, 19 minus 15, 10, 13, minus 15, 19 minus 10, 19 minus 13, and I'll pull up my calculator. I can put all of them in or just finish simplifying them. So the area by Heron's formula is going to be 19 multiplied, 19 minus 15 is 4, 19 minus 10 is 9, 19 minus 13 is 6. And then I'm going to put this in my calculator. All right, so I'm going to clear second square root. All right, 19 multiply 4 multiplied by 9 multiplied by 6. And then I hit enter. So this is the area of the triangle. Let me see, in square unit, by the way. So let's not forget that is square unit. So we go to square meters. So the area is 64 square meters. I don't know, just let's check and see. So if you're told to use 1 decimal point, then it's 64.1 square meters. So the area in that, this is just a reminder of your geometry, so you can do this. And so we're actually going to stop here because that's all I have. We have done sine and cosine rule. Let me see. We did sine and cosine rule. So we can actually answer any other question here. Can actually answer any other question. Okay, so the applications we're going to